we're going to look at graphing logarithms, and we're going to do the same as we did with exponential functions, where we are going to use transformations. So we need a parent function. So the graph of f of x is equal to log x has a couple different properties that you'll want to just memorize or know. So one thing is I cannot evaluate a negative log. I can't have a negative number inside the log, inside this argument. So x cannot be negative. So what that does is put a vertical asymptote at x is equal to 0. And we'll want you to always state that. So we'll say vertical asymptote x is equal to 0 in this case. And then the log function, if I evaluate for 1, anything to the 0 power is 1. And so the 0.01 is going to be on your graph as like an initial point, and that's one we can shift around, or an initial value. And then from there, it's going to depend on the base of the log, but it's going to have a shape that looks something like this as just a sketch. And when we draw these graphs, 1 point's enough, and then you can just have the sketch of it. The domain of the graph will always have the vertical asymptote as part of it. The domain, in this case, goes from 0 to infinity. The furthest left, it goes to 0. It doesn't actually touch 0, so we use a parenthesis. The furthest right is infinity. And the range goes from negative infinity to infinity. So these graphs, and as you like graph these on your calculator and stuff, they look like they kind of level off, but they do continue to increase just slowly. So the range would be from negative infinity to infinity. Okay, let's call that number 1 and number 2. Let's shift these around a little bit. We can shift these the same way we've shifted all of our functions and transform them. So let's say if I wanted to do like log, let's give a different base. So that's base 2, and then x minus 2. Actually, let's not use 2. So we just use 2. Let's do x minus 3, and then plus 1. Okay, so first, like this, we call this number down here, this is the base of the log. For the graph, what that means, what that will do is this line will go up either quicker or slower depending on the base. As when we graph these, we're not worried as much about that. It'll change the points you get. If you wanted to get more points from the table, it would change those values. But if you know the transformations and you know the domain and range and the asymptote, then you're good to go. So let's look at an example here, or let's look at this graph. So we're going to start from this point 1, 0, as it would be on the graph before any transformations are made. But then this negative 3 is going to move everything to the right 1, or sorry, to the right 3. And anything inside the parentheses moves it left or right. And you need to change the sign. And then this 1 is going to move everything up 1. And so I'm just going to take this point and I'm going to move it right 3. So 1, 2, 3, over at 4, and then up 1. And so now this point is on my graph. My asymptote was at x equals 0 from the parent function, but it's going to move right 3 as well. So the asymptote's going to move with the graph if I go left or right. So 1, 2, 3, and here is my asymptote. And so let's go ahead and write that. Our vertical asymptote is at x is equal to 3. Our domain is from 3 to infinity. Notice that pattern, that the 3 is included, or the vertical asymptote is included in the domain. And then your range goes from negative infinity to infinity. So these are the things that we will ask for and you'll need to be able to do. You'll need to be able to state the transformations, the vertical asymptote, domain and range, and then a sketch of the graph with this point, an asymptote, and then the graph itself. Just a sketch is fine though, so just as long as it goes to that 1 point, it's okay.